Hi again, this is Glenn Langston. I'm actually now showing you the parts you're going to need to build your sort of the basically what we're calling the feed, the RF feed that will allow you to gather up into your 1 foot tall, 10-inch wide bucket, which is just a galvanized metal container. The signals from the Milky Way, they actually go into a thing called a feed, well, we're calling a feed probe anyway, which is this thing, which is just a very small, it's actually 5 centimeters long, and I'm using silver for the wires because it doesn't tarnish, but it's very inexpensive, well, fairly inexpensive jewelry wire. It's easy to come by. This is 21 gauge, and it attaches to a SMA connector, and you would normally put some kind of a cable there, but we just add this silver wire to the end. Now this wire is actually, like I said, easily available and not too expensive at all, and a little coil of it, this is like 5 inches wide, can make many feeds. Our cat is looking at the process. The other things you're going to need is actually one good quality coaxial cable, this one is I believe it's RG 400. I'll actually have to 400 and something. It actually is good to 3 gigahertz, which is, you need it to be a fairly high frequency cable. You need one of these. You only come in a 2-pack, but this is just a 6-inch long connector before connecting cables together. You do need one good, this is a critical part of it. I showed you in the previous video a GPIO Labs amplifier, but this is the Newek H1 amplifier, which is 2 amplifiers with a filter in the middle. And that's critical because the filter has to get rid of, basically we're our own worst enemy. We have so many digital things like this phone that cause corruption in the signal. And then the tools you need for this part of the RF part of your telescope is a 1/8 inch drill bit to actually drill a pilot hole, and then a 1/4 inch drill bit for the SMA connector. And we're going to put exactly 1 hole in this can here at exactly the right distance, which is 7.4 centimeters from the bottom of the pan. And then we will drill that 1 hole and stick this feed probe in it in a second. Now, it turns out that we're going to make an RF everything you do has to be to try to reduce the interference. So we're using just a standard peanut butter jar. This is the wide one. It's 3.5 inches wide. So you'll have to enjoy a good bit of peanut butter sandwiches before you start this project, but essentially we're calling this free. And you could maybe do fundraising and sell peanut butter sandwiches for radio astronomy, which would be good. This bucket is like $35. This amplifier is $50. The other one's about $50 too. These cables is like $15. These bits and pieces here are another couple dollars. The feed probes are not expensive, but they're a little bit of a headache to make. So I'll give 50 of them out. So far I've given out 5. So if you email me, I will try to send you one as quick as I can. Another thing that's important, this is actually what's called a termination. This is actually sort of causes a signal on the amplifier to just be whatever the temperature of the room is. And it turns out the room temperature is about 10 billionths of a volt is inside of everything, including this little metal thing. And this will actually be more signal than you'll get from the sky. But because of the design of this, we'll actually be able to easily see the Milky Way when we put it together. But this is a good test component. This is called a 50 ohm terminator. So that's it. So we'll get started putting this together in a second.